Good afternoon. Many thanks for joining this ELIXIR webinar. I'm very happy to share with you the work we've been doing over the past 2 years. So my name is Kristin Durings and I'm leading the ELIXIR data platform together with Joe McIntyre and our platform coordinator Rachel Drysdale, who is also on the line. My other role is being the Associate Director of SIB, Swiss Institute of Bioinformatics. Today, it's very difficult to imagine doing any life science research without being able to rely on data resources. In addition, and especially for data related to publicly funded research, both funders and researchers expect these data to be openly available for anybody. However, open data requires a real infrastructure, a dedicated infrastructure. And ELIXIR is building such a sustainable infrastructure for biological information, so that life scientists find information that is essential to them, to their research, and so that they can safely deposit and share their precious research results. ELIXIR's mission is achieved by essentially providing 3 things: the ELIXIR network and expertise, the ELIXIR services that form the backbone of the ELIXIR life science data infrastructure, facilitating stable access to data, and the ELIXIR Core Data Resources. We will also briefly discuss the ELIXIR Deposition databases, so the need for this emerging collection crystallized out of the first core data resource selection process. Although today's life science research relies on data resources, in a survey done during the ELIXIR preparation phase among 200 resource managers, it was found that 2/3 of databases have no or 1 year of assured funding. And a study by Terry Atwood and colleagues has shown that after 15 years, this is what happened to 326 public life science databases. So 23% of them was alive, albeit rebranded for some of them, meaning that the data had been integrated in another database. 14% was archived, with the data still accessible and searchable, but no longer updated, and 62%, so 2/3, was dead. So maybe some of them were just bad databases, and survival of the fittest is a good way to keep the database population healthy. It's important to keep in mind that researchers have confided their research results to these databases, and the fact that their existence is so unstable is associated with the loss of an immense wealth of biological information and the associated investments. So I think you will agree with me that improving the long-term sustainability of databases is therefore highly needed. With the current strong trend towards open access of data, there is an urgent need to establish an international funding mechanism to ensure the long-term sustainability of core data resources. So last November, a global coalition was established with a common goal of sustaining essential data resources. 30 representatives from widely used data resources, but also funders and scientific organizations participated in an international workshop in Strasbourg. They exchanged information on possibilities to develop a roadmap for the future growth and accessibility of essential data resources. The results of this workshop have been made public in a correspondence article published in Nature, and also a full article that you can find on bioRxiv. This year, so in the month of June, a second meeting took place. So in the article, it's explained that to be able to design and implement an international plan for long-term sustainability, the first step is to determine which data resources are of fundamental, so core importance to global life science research. To be able to identify these, objective indicators are needed. And in the future, these core data resources will be eligible for shared international support. Countries need to share the funding burden since these essential resources are too big for single countries or funders to carry. So when starting the work on the ELIXIR Core Data Resources, we asked ourselves the question, which databases are essential? And we defined the ELIXIR Core Data Resources as a set of data resources that are of fundamental importance to the broad life science community and the long-term preservation of biological data. They provide complete collections of generic value to life science, and they show high levels of usage, scientific quality, and service. As each data resource has its own specificities, we've opted for a carefully chosen set of indicators reflecting the multiple facets of bioinformatics resources. We've grouped the indicators in 5 categories. The first category measures scientific focus. The second one, the community served by the resource. We also measure quality of service, legal and funding infrastructure and governance, and last but not least, impact. So we'll now go through the different categories in more detail. So first of all, within the category of scientific focus, a differentiation should be made between deposition databases that receive and archive de novo datasets and well-structured metadata deposited by scientists versus added value databases or knowledge bases, which are based on the archival data and they are really adding substantial value through expert curation, through carefully annotated metadata, data processing, and data integration. So the curation effort linked to a certain resource is an important measure of its quality, and other indicators included here are the positioning of the resource compared to other resources and whether the resource is an authority in its field. The community served category reflects the size and the measured demand of the communities that are served by the resource. So this community that is served can be both people, users depositing, as some resources are vital for deposition, and also the end users of the data. There are different ways to identify and measure the community, such as web statistics, international reach of the resource, and the citation of the data and the data resources in publications in the literature. The scientific context in which the resource operates should be taken into account. You can have a resource that serves a small scientific community and that may not have as many users as a resource serving a broader interest, and yet it may reach 90% of the community it supports and be crucial for the scientific work of that community. In addition, certain resources play a foundational role to derived resources and or services that rely on their existence, hence the dependency of other resources as one of the metrics. Then the third category is measuring the quality of the service a resource offers as well as its reliability. It includes the use of unique identifiers, parameters like response time and uptime, and the existence of a help desk and training activities. The long-term stability of data resources depends very much on the soundness of their governance. For example, ELIXIR Core Data Resources regularly receive critical advice by a scientific advisory board. And another important element is the license under which the resource operates. We will come back to this a little bit later in this presentation. Then the last category is an important one, as it measures whether the data resource fulfills the need it tries to meet. It's done through describing what happens if the resource would no longer exist, so establishing the counterfactual. An example is users who would simply be unable to do their research if the resource would no longer exist. Another example is by showing the number of patents that cite a database or data in a database, giving an idea of the impact on the private sector. So if you would like to have more details, all these indicators and the process are described in great detail in the report, and that is available on the Faculty 1000 Research ELIXIR channel. In the context of Horizon 2020, there's a lot of focus on making data fair, so findable, accessible, interoperable, and reusable. So we asked ourselves the question how fair our indicators are. So from this mapping table, you can see that each FAIR principle on the left is covered by at least one core data resource indicator. However, you can also see that the core data resource indicators do much more than measuring fairness. They measure the scientific need, the community served, and importantly, the impact of the resource. They can therefore be used to support decisions on value. Now that we have defined what good looks like, it can help guide you when developing a data resource. So a data resource typically starts from a research project, and the indicators provide quality standards that guide and inform the managers of emerging resources in the development of their resource, and later they help monitoring usage trends as well as the scientific impact to support their life cycle management, or when appropriate, leading a resource towards the legacy stage. So let's summarize why the indicators are useful and also why we want to identify core data resources. So we need indicators to identify the core data resources because transparent indicators provide funders and policymakers with information on resource quality and impact. They support science policy making, as the funding of core data resources will have to be shared internationally. The indicators also give resource managers guidance, and they are spreading excellence in resource management, making resources better. And hopefully this will make Europe's life science research infrastructure competitive and driven by excellence, further strengthening the European position. As you will see from the identification process, the indicators are meant to support human judgment, so they're not a calculated score that gives you a yes or no answer. So this is the process that was used to establish the first list of ELIXIR Core Data Resources. The ELIXIR nodes have put forward the candidate resources via the case document that you can find in the Faculty 1000 paper. The 26 applications that were received at the hub were checked for completeness at the hub, and it's the Heads of Nodes Committee that has established the list with the precious input from a panel of independent experts and the Scientific Advisory Board. During the identification process, a number of discussion points came up, and we will now discuss the most important ones. So the first one is the breadth of the coverage of a resource as well as the community served. So the definition of ELIXIR Core Data Resources includes terms such as the broad life science community of generic value to life science, as opposed to being very specialized. So life science resources such as UniProt or NENA, they are clearly having a very broad scope and user base. But how can we decide at which point the narrowness of a resource means it becomes non-core? And how much should the core data resource definition be determined by usage numbers? Given that everyone from a small specialized community is using a resource, does that mean it is a core resource? An element that may be helpful is integrating in the discussion the consideration of the impact of the resource beyond the core community into the wider life science community. Half of the 26 submitted cases are pure knowledge bases, 5 resources are pure archives, and 6 are defined or have been defined themselves as both archives and knowledge bases. So the distinction is not completely clear, as most deposition databases provide value-adding and analytical capabilities for the archives datasets. During the process, it became clear that it would be helpful to separate the discussion on deposition databases from the one on knowledge bases. And in many fields, knowledge bases provide a needed authoritative source, and the discussion is largely based on utility, as shown, for example, by a large user community. A data infrastructure should provide deposition databases to deposit most kinds of biological data, and the scope of a deposition database can therefore be narrow without its coreness being questioned. A second major theme are the nested resources. So bringing resources together to form a consortium is obviously valuable, and there are several successful examples in the application for core data resources. Redundancy can be a strength, and a consortium can allow for a funding diversity that makes the resources more sustainable. Consortia often contain resources of similar scope, and the question arose whether individual databases within a consortium can be considered core in addition to the consortium. So after many discussions, we have opted for not identifying individual resources within the consortium as core unless they make a unique contribution to the data resource landscape, independently of the aspects for which they participate in the consortium. So the Interpro consortium, which includes 14 databases, is a core data resource, but also CAT, which is a member of the Interpro consortium, but also a core data resource on its own. So as the coreness of a consortium resource such as Interpro is based on the contributing databases, it should be emphasized that in naming an umbrella resource as a core data resource, the critical role of the constituent databases is recognized. Hence, the footnote that you will find under Interpro in the core data resource list that has been published. And then a third major theme is the license under which the resources operate. ELIXIR is committed to open access as a core principle for publicly funded research. So the ELIXIR Core Data Resources should reflect this commitment and have terms of use or a license that enables the reuse and remixing of data. The Creative Commons licenses CC0, CC BY, or CC BY SA, they are all conformant with the open definition that you can find on the opendefinition.org/licenses website, as are equivalent open terms of use. So this is the current set of ELIXIR Core Data Resources. They vary from deposition databases to highly dynamic knowledge bases, and Interpro is an example of a consortium database in which the crucial role of participating databases must be recognized. This list is a dynamic list, so it will change, meaning or grow or shrink, to reflect the evolving scientific needs. During the core data resource identification process, in discussions with different stakeholders, it became more and more clear that funders and journals were looking for guidance regarding data management policies and plans. So the ELIXIR Deposition Databases list aims to provide guidance to those who formulate policy and working practices about the appropriate repositories for publishing open data in the life sciences. An ELIXIR Deposition database is defined as being part of an ELIXIR node portfolio of services. It accepts deposition of experimental data from an international community of researchers beyond the funding envelope of the database itself. And the ELIXIR Deposition databases meet the technical quality and governance criteria expected of the ELIXIR Core Data Resources. They may, however, be at an earlier stage of development, meeting an emerging scientific requirement, or maybe narrower in scope. So consequently, some but not all of the ELIXIR Deposition databases also appear in the ELIXIR Core Data Resources list. You can find the list on the ELIXIR website under the data platform. So to close this webinar, I would like to come back to one of my first slides. The landscape of data infrastructure will continue to evolve in the future. There will be another round of selection of core data resources in 2018. And in October, so next month, the ELIXIR data platform will bring together the core data resources within a forum. On the agenda will be a publication on statistics linked to the core data resources, as well as discussing how the ELIXIR core data resources will be feeding into the global data resource coalition. I would like to thank you for joining us today for this webinar, and on behalf of the data platform, the teams in the EBI, the Swiss and the Spanish ELIXIR nodes, as well as the ELIXIR Hub, who all contributed to this work. We would also like to thank our funder, the European Commission, for making this work possible, and I'm happy to take any questions you may have.